1 1 and on 2 in composition with phi, as well as it is the 1 1 and on 2 with composition of psi. Let us define it again. This is the element, and this element is known as G dash, and we have earlier seen that this element G dash is also the mapping of G, and this mapping is 1 1. We have already written it earlier. 1 1 and on 2, 1 1 and on 2, this mapping is 1 1 and on 2. But here we have established a relation between phi and psi. If phi is possible, then another mapping is also possible from other domain, and this is a group which is having the elements of G upon K. And here we have seen that there is a mapping, because there is a relation between phi and psi. It means if phi is existing, then psi will also exist. It means this G dash will be the mapping of another element Gk, which we have seen here. So if this G dash is on to with respect to phi, so this G dash will also be on to with respect to psi, because there is a relation between phi and psi. So here we have shown that the psi is existing, psi is 1 1 and psi is on to. So here we have proved the psi is 1 1 and on 2. Now we wish to show that this psi is homomorphism also. If the psi is homomorphism 1 1 and on 2, then it will be isomorphic. However, we have seen that this psi is 1 1, as phi is 1 1 and there is a relation between phi and psi. But we can also define it separately, as mentioned here. If there are two elements whose mapping are equivalent for psi, because psi can be replaced by another mapping phi, because the phi of G is equivalent to psi of Gk. Similarly, in right hand side, again we are multiplying both sides by phi of G inverse. Here we are applying the definition of homomorphism, because phi is homomorphism, and solving this in this manner, we are seeing that this Gk is equivalent to G1k. It means if we are taking the image of two elements, if the image of two elements are equal, then these elements will be also equal. So this psi is 1 1 also. And in last, we are testing that it is homomorphism or not. Let us suppose there are two elements and we want to find the mapping of the product of these two elements. Then this it can be written as psi, as we know that this is the property of coset. If Gk is being multiplied with G1k, then it can be written as Gg1k. This is the definition of coset, the property of coset. Again, we are applying here the definition of phi in terms of, we are replacing the definition of psi in terms of phi, as we know that the phi of G, which is equal to the psi of Gk. So if you are replacing your psi with phi, then this k will be omitted from here. So here we are omitted this. Again we are writing it as phi of Gg1. Again we are applying the definition of homomorphism. Again we are replacing the definition of phi in terms of psi, so this k will be uh, appear here. So here we are seeing that if we want to find the product of two elements, and we want to find the image of the product of two elements, then it will be equivalent to the product of their images. So here this psi is also homomorphism. So in this theorem, first we will elaborate the property of phi, and phi is epimorphism. Epimorphism means it is a homomorphism and it is onto. So if it is homomorphism and it is onto, we have earlier shown that it is 1 1 also. But first we have established a relation between phi and psi, and after establishing the relation between phi and psi, we wish to show that phi is 1 1, psi is 1 1, psi is onto, and psi is homomorphism. There are 4 points here. I am repeating again. There are 4 points here. In the first point, you will establish a relation between phi and psi, so that you could replace your phi with psi and psi with phi as per your convenience. After establishing the relation between phi and psi, again you will prove psi is well defined, psi is 1 1 and psi is on 2, and up and in the last you will show that this psi is homomorphism. So if it is homomorphism 1 1 and on 2, so that you can say and this psi is uh, isomorphism. So if you have any confusion or at any step of this theorem, you can contact me personally or in group chat, and you can also discuss it in a doubt session. There are two more theorems remaining here, the second isomorphic theorem and third isomorphic theorem. And after completing these two theorems, the syllabus will be completed and we will take your doubts only. So I'm waiting for your doubts in this theorem. Thank you so much.